Now let's go ahead and determine the domain and range of a quadratic function by looking at the corresponding parabola. Down below, we have two different parabolas, one that opens up and another one that opens down. In both instances of this graph, we don't see any jumps or any undefined points, and so we can see that the domain of these graphs are negative infinity to infinity. Now, we see that the range of these graphs really depends on if our parabola opens up or our parabola opens down. Recall that for a parabola that opens down, the vertex is the highest point, and for a parabola that opens up, the vertex is the lowest point. This means that the y values of a parabola that opens up goes from k to infinity, and for a parabola that opens down, our y values are going from negative infinity all the way up to k. We summarize the range as follows then. Before we go any further, let me note that, again, h is equal to a negative b divided by 2a, and k is equal to f evaluated at h. Now, let's find the domain and the range of f of x is equal to 2 of x minus 4 divided by 7 raised to the second plus 8 divided by 11. The easiest way first is always to draw a picture. Again, we know that this 2 indicates that our parabola is going to open up, and these points correspond to our vertex. So the vertex of this parabola is equal to 4 divided by 7 and then 8 divided by 11. This lies in the first quadrant, and since our parabola opens up, we have a picture that looks like this. The y value, again, of our vertex is given by 8 divided by 11. So the y values of our parabola go from 8 divided by 11 to infinity. We know the domain, then, of any parabola is always negative infinity to infinity, and the range of this specific parabola by the graph that we just drew is 8 divided by 11 to infinity. Let's find the general form of a quadratic function that contains a point negative 1, 5, has a stretch factor of 3, and whose vertex is on the y-axis. There's many different ways to solve this problem. In this particular instance, what we're going to do is we're going to find the standard form and then simplify it out. So let's go ahead and look at some of the information that we're given. First, this quadratic function has a stretch factor of 3. This means that our a is going to be equal to 3. The next thing that we know is that the vertex lies on the y-axis. So let's draw a picture of what we have so far. We don't know specifically where the vertex is. We know it's just somewhere on the y-axis. And we also know that a parabola opens up somehow. So maybe our parabola looks like this. Plugging what we do know into our standard form, we'll get y is equal to 3 times x minus h raised to the second plus k. Now, since we know the vertex lies on the y-axis, we know x is going to be 0, and k is some number that we don't know. So we can simplify this down one step. This is going to be 3 times x raised to the second plus k. The only thing we're missing now is this k here. So what we're going to do is we're going to use the last piece of information that we haven't used yet, plug it into the equation, and solve for k. So plugging in our information, we'll get that 5 is equal to 3 times a negative 1 squared plus k, which means k is equal to 2. Well, now that we have k, we have the solution to our problem, because plugging k into this equation here we'll get that this is equivalent to y is equal to 3x squared plus 2. And it turns out that this is both the standard form in this case, but also the general form.